Hello to everyone. My name is Matteo Centia and I'm going to present the paper Grading Evolution and Critical State in a Discrete Numerical Model of Fontainebleau Sand. The work was developed together with Marcos Arroyo, Catherine Sullivan, Antonio Jens, and Ting Fa Liu. In a nutshell, in the paper, the discrete element method is used to study the critical state theory of crushable granular materials. The results support the theory of multiple critical state lines in the compression plane and shows that they all belong to a unique critical state plane. As you can see, a plane needs three axes, so the grading index is introduced to track particle size distribution. How this is done, I mentioned DM, but basically we need a crushing DM model, which in this case is very easy to calibrate, as you just need single particle crushing tests, and as for all the other DM models, low pressure triaxial test data to calibrate. Once the model is calibrated, you can see how it's able to replicate real experimental data, for example, of high pressure shearing of Fontainebleau sand. This taken from the literature. As I was mentioning, there is the grading index, and the DM model is able to track this systematically throughout the simulations, and we see how it can capture well the experimental data points. So once we had calibrated DM model, it was used systematically, taking advantage of the fact that we have a DM model where we can switch on and off crushing, and therefore identify multiple critical state lines for variable grading indexes, so for variable particle size distribution. I mentioned that the main output or result is the fact that we identified a critical state plane that can be described by equation 2. The most important result, in my opinion, and couldn't be published in the paper, is the fact that later on, experimental data of high pressure shearing data was published by Al-Tohafi and others, and the critical state plane calibrated on DM only results was able to capture this data quite efficiently. So I would call this class A prediction. The critical state plane equation is also able to capture Dogs Bay sand and touching rockfill, so other granular materials. In conclusion, I would say that the critical state for crushable granular materials lies in a unique critical state plane. I would like to acknowledge the Junior Research Fellowship that funded the work, and if you want to download the references of the poster, the paper itself, or the poster, please use the QR codes. Thank you for your attention and see you in London.